Hi everyone, and welcome back. This is our fifth question about the magnetic circuit. Uh, so in this question here, we have magnetic material, and here we have two coils instead of one coil as we have seen in the previous questions. So this is something that we need to pay attention to. We are given N1 600 turns, and we are giving the current as I1 equal to 0.5 amps. We are given N2, which is 200 turns, and I2 is equal to 1 amp. We are given the dimension of the core material. There is no air gap here, but we are not given mu r. Instead, we are giving the BH curve. So the x-axis here is the H, and the y-axis is the B, the flux density and the magnetization or the magnetizing intensity, H. Okay, so what we want to find, how much flux is produced in the core. So we want to find phi. Now, since this is everything in series, we will have only one flux. And what is the relative permeability? We want to find also what is mu r, because it's not given to us. Okay, so that's a different question. And in this question here, we are having the saturation curve. This BH is called the saturation curve. Okay, let's see how we'll proceed with this question. So the first thing we need to draw the circuit, okay, as usual. So here we have two MMF. So the first one, using the right hand side, the flux will be going up and the polarity will be plus minus. I will call this as MMF1. Now for the other one, to the right hand side, the second MMF, the flux will be going down. So it's the same direction actually. So the polarity here will be minus plus. So these two polarity will be additive. And then we have only the reluctance of the core. This is MMF2. So MMF1 and 2, they can be added together because they are with the same direction. The first one will produce the flux in this direction. The second one will produce a flux in this direction, which is exactly the same thing. Okay, so the total MMF of the circuit is equal to MMF1 plus MMF2, and this will give us N1 I1 plus N2 I2, and this is equal to your N1 is 600 turns, the number of turns, times the current, which is zero 0.5, plus the second number of turns, which is 200 times 1, and this will give me 500 ampere turn. Okay, now what is this? This is your Ni, but Ni is equal to H times L. H is the magnetic field intensity and L is the mean path. Okay, so what is the mean path? It is the mean path that we calculate all the time. So it's a distance between here to here to here until we, so this is your L. So what is L? L will be equal to the distance, which is the 50 centimeter, which is from here to here, 50 centimeter, plus half the distance to the right, half the distance to the left, so plus 7.5 plus 7.5 centimeters. And because of the symmetry, it's the same thing in the four sides, so multiply it by 4 times 4. So the total L that we will have is basically 260 centimeter or equal 2.66 meter. So from this we can find H. Your H is equal to the 500 divided by the 2.6, which is equal to the H value, that which is equal to 192 ampere turn per meter. Okay, how we can benefit from this H? Now you go back to the curve that we have, and this H192, using the curve, you try to find what is the corresponding value of B here. Okay, so B here is approximately is equal to 0.17 Tesla. You might not get the exact value, okay, but any approximation around this number will be fine. So from this, your B is equal to 0.17 Tesla. Now, if I know B, which is equal to the flux divided by A, from this, your flux is equal to B times A. And this is a very uniform cross-section area because the width in all section is 15 centimeter and the depth is also 15 centimeter. So your flux phi is equal to the 0.17 times the cross-section area, which is 0.15 times 0.15, and this will give me 0.00383 Weber. So this is your flux. Okay. Then we want to find the second thing. We want to find the relative permeability. Now we know B and we know H. Okay. Mu is basically equal to B divided by H, which is 0.17 divided by 192, and this is equal to 8.854 times 10 to the minus 4. But this is equal to mu 0 times mu r, because this is total mu. So from this, you can find your mu r is equal to 8.854 times 10 to minus 4 divided by 4 pi times 10 to minus 7. And from this, you will find this is approximately is equal to 7004. This is your relative permeability.